The last topic for section 6.1 is formulas. Okay, so in the next section, 6.2, we're going to talk about equations. Okay, we're going to talk about them extensively then. Right now, I just want to kind of let you know, just sort of quickly, what is an equation. We'll talk much more about them later. For now, just know that an equation, let me go back to yellow. An equation is formed when an equal sign is placed between two algebraic expressions. So another way to think of this is it is a mathematical statement that two expressions are equal. So the big difference between an expression and an equation is that equal sign. An equation has an equal sign, an expression does not. That's what you need to know right now. We'll dig in much deeper later. Okay. Now, a formula is an equation that uses variables to express a relationship between two or more quantities. So formulas are kind of like real world equations. Okay. They take relationships that exist or that we create and they use variables to kind of show this relationship. Okay. So, really classic formulas would be like if we're talking about the perimeter of a rectangle, we know that the perimeter P, a variable of a rectangle, is 2 times the length plus 2 times the width. That's an example of a formula. Okay, so we use formulas all the time. All right. Now, in this example that we're going to look at, this is directly from your textbook. Okay, so you've paid to use your textbook. Let's take as much from it as we can. So you might see this example in homework. If you go to your ebook, you'll see this example. It's just so good, I didn't want to try to recreate it. Okay. So it says, consider the following information. The following bar graph shows the estimated number of calories per day needed to maintain energy balance for various sex and age groups for moderately active lifestyles. Okay, so you can see along what we would consider like the y-axis. So this stuff right here. Okay, this is our y-axis. We'll talk more about that later too. But along this, we'll call it vertical axis, we have the calories per day. Along the horizontal axis, or what we will later lovingly call the x-axis, we have the different age groups, okay? So we look at ages 4 to 8, 9 to 13, 14 to 18, 19 to 30, 31 to 50, and then 51 plus, okay? And what I really want you to notice is the group number. You can already see here we have kind of like they call it a key to our table here. We know that the red bar represents female, the yellow bar represents male, and you can see that generally speaking, males need more calories than females, okay? But the most important thing here that's sort of confusing is the group number is actually really important. We can't plug this into a formula. We can't plug 19 to 30 because we're saying it's the same for 19 to 30. So instead, what this formula that you're going to see in just a bit does is it says, hey, for this age group, we're going to let x equal 1. For this age group, we're going to let x equal 2, then x equals 3, x equals 4, x equals 5, and x equals 6. So the group number is what we're really looking for when we go to consider each different age group. That'll make more sense in just a bit, but I really wanted to point that out, okay? Now, below this table, we have the mathematical model. So when we talk about a mathematical model, we mean an equation or an expression, frequently an equation, but an equation or an expression that represents some real world situation. So like I said, frequently this is going to be some kind of an equation or a formula. Okay. So another word for a formula could be a mathematical model. It's just some equation that represents some real world situation. So we are told that the mathematical model M equals negative 120x squared plus 998x plus 590 describes the number of calories needed per day M by males in the age group X. So remember, we're saying the age group, that's going to be our X value with moderately active lifestyles. So this is the formula or the model that we're going to use. And what we'll ultimately end up doing is we're going to compare the result we get from the model to this table of values, okay, or this graph. So it says down here, example 5, it says use the information above to answer the following questions, okay? So part A says, according to the model, how many calories per day are needed by males in the 51 plus age group? This is age group 6, which means x equals 6. Okay, so what we want to do is we want to understand that the model is the formula, not the graph. Okay, so we want to take this model and anywhere we see an x, we want to replace it with the age group, which is 6. Okay, so we get m equals negative 120 times 6 squared plus 998 times 6 plus 590. Essentially, what we're doing is we're just evaluating. So remember a couple of videos ago, we talked about evaluating algebraic expressions. We're doing the same thing right here. We're replacing the value for x with some given number, okay? So let's see, we can just go straight to the calculator on this one. I'm going to type this into my handheld calculator, then we'll go to the calculator screen. I just don't have the paper worksheet sitting in front of me. So, okay, so let's go to the calculator screen. I have it written down, typed, whatever, so that I don't forget it. Okay, so here is the calculator. All right, so what we had was negative. So let me do this really quick. If you use this graphing calculator, okay, there is a negative button and there is a minus button. And you have to be really, really careful with which one you choose. Since we're talking about negative 120x squared, we want to use the negative button, not the minus button, okay? I know that seems nitpicky, but it does matter on this calculator. So if you go to the very bottom row of buttons beside enter, you have like little parentheses with a minus in it. That's your negative, okay? So we want to type in negative 120 and then times 6 squared. Remember, it was negative 120x squared, but our age group is 6. Okay. And then we want to go plus 998 times 6. Notice I'm not hitting multiply. I'm just using parentheses. The parentheses can act as multiplication here. And then finally, plus 590. And then if we hit enter, it'll tell us approximately how many calories males in that particular age group need if they have a moderately active lifestyle. So hit enter, and this says that men in that age group need 2,258 calories. So let's go back to the worksheet. So we need 2,258 calories. Whenever you do a word problem or anything that has like a real world application, put labels with your answer. Describe your answer somehow. If at the very least you can put units, but some kind of description is always nice. Okay. Now, part B says, does the model, the formula that we just did, does it overestimate or underestimate the calories needed by males in the 51 plus age group shown in the graph? So let's go to the 51 plus age group. Remember, we're talking about males, which are going to be in the yellow bar. And we're looking at age group 6, which is right here. That was 51 plus. And according to the graph, males need 2,300 or 2,300 calories. Okay, so on the graph, they need 2,300 calories. According to the model, it was pretty close. It did a good job estimating in this case. It said that we need 2,258 calories. So what I would say is the model underestimates. And I'm going to go ahead and put slightly the calories needed. It's pretty close though. All right, so we have this model that's going to do a good job at estimating the number of calories that different age groups and different sex groups need. So we're looking male, female, and then different age groups, okay? So let's look at C and D. So C says, according to the model, how many calories? Oh, this is a typo. Please don't be upset with me. I try so hard not to have typos, and dadgummit, they're there every time. This should say males. I was probably copying and pasting. So this is males. Please fix that in your notes, okay? I'm really, really sorry about that one. So part C says, according to the model, how many calories per day are needed by males in the 14 to 18 age group? Now remember, this is age group 3, so that means X equals 3, okay? So please recall, this is our model right here. So we have m equals negative 120x squared plus 998x plus 590. So we want m equals negative 120x squared, but x, remember, we're evaluating here. X is going to be 3 What was it? Plus 998 x. Yeah. So plus 998 times x, which is 3, and then plus 590. Okay. So let's go back to the calculator, and I'm going to show you a trick if you have the graphing calculator. Let's see. So instead of having to type this in again, there's a couple of ways you can do evaluating. You can store a value into your calculator, which is something I can show you otherwise. But for now, we've already typed in the equation, all right, or the formula. We just had x equals 6. So what I can do is I can just hit the up arrow. This works on this type of calculator, not necessarily every calculator, but I can highlight the previous time I typed this in and then hit enter. And then all I have to do is go backwards and type over the 6 with a 3. And that way I don't have to type in the whole formula. Now, for some of you, it might be just as easy to type in the whole formula again. That's fine. If you know how to store values into your calculator, you can also store values into your calculator, and then you can just type this once and then change your store value. There's different tricks, but well, that's a different topic for a different day. So let's hit enter. And this says for males in, I think it was 14 to 18 age group, they need 2,504 calories. So let's go back to the worksheet. So we have, scroll down just a little bit. We have the M is 2,504 calories. Okay, so that was for males in the 14 to 18 year age group. Okay, now let's go back and compare that to the graph. That's what part D says. It says, does the model, the formula, overestimate or underestimate the calories needed by males in the 14 to 18 year age group shown in the graph? So let's go back to the graph. 14 to 18 is right here. All right, and you can see here that according to the graph in the 14 to 18 age group, males actually need 2,600 calories. So in this age group, it definitely underestimates again, but it underestimates a bit more. It's a little bit more off compared to the 51 plus age group. But for the graph, we have that they need 2,600 calories. All right, so we would say the model, which is the formula, the equation, the model underestimates the calories needed. So we could say, generally speaking, for at least the two examples we looked at, the model's pretty good. It gets close. It does tend to underestimate compared to the graph, but we haven't checked all the age groups to compare. But we could say with these two examples, the model tends to underestimate things. Okay, so that is a formula. It's very real world. It also gives you the chance to look at a graph, look at a model. Kind of lots going on here. Again, this was completely stolen. I don't want to say stolen. That sounds awful. You all paid for the book, so we can use stuff in the book. But this does come directly from your book, so you may see stuff like this in Pearson or in your ebook. Okay.